ASP.NET gives web application developers access to the .NET framework. You can build applications on ASP.NET in the Google Cloud. In this module, we'll show you how.
In this module, we'll look at how to create a web application using Microsoft's ASP.NET MVC framework on Google Cloud Platform Compute Engine. In Module 2 of this class, we looked at how to provision our Microsoft Windows Server and Microsoft SQL Server infrastructure. We've got an Active Directory domain controller, a web server running Microsoft Internet Information Services, and a pair of Microsoft SQL Server instances running in an always-on availability group. Now it's time to build an application. We'll be coding a simple ASP.NET MVC application using C#. And if you're a developer working with Microsoft technologies, you'll know that this is a great way to build a web application. We'll use Microsoft Visual Studio as our integrated development environment, and we'll publish our application to Internet Information Services using Google Cloud Tools for Visual Studio. If you're not a developer, just be aware that a web application delivers application functionality using a standard web browser. The browser accesses the application as a URL, and the server responds with dynamic output generated from data. In our case, from data stored in Microsoft SQL Server. ASP.NET MVC makes use of a widely used application architecture called Model View Controller. This architecture is frequently used when writing web applications. It allows for a clean separation of concerns between modeling, manipulating, and displaying data. Here's the first participant of our MVC application, the model. In an MVC application, the model's responsibility is to represent the application data and business rules. In this example, we've created a model class using C# called Contact. We'll use this to build an address book application. We can see that the Contact class defines a set of properties, and in our application, we'll use this class to create contact objects. Each contact will have its own name, email address, and cell phone number. Of course, in a more full-featured application, the contact would have many more characteristics, but then it wouldn't fit on a single slide. In addition, our contact has a numeric ID. We'll make use of Microsoft Entity Framework to simplify integration with Microsoft SQL Server. The ID will be used to enable us to map each contact object to a record in a database table. The next player in MVC is the view. The view's responsibility is to present model data to the user and also to display forms that allow users to enter data to be collected by the application. We've written our view using a templating language called Razor. A Razor file is easy to understand if you know HTML, as the templates are written with HTML markup and embedded code. Our example shows a fragment of a Razor file with C# code, and will have a .cshtml extension, as it consists of C# code and HTML markup. You'll notice in our example that this template makes use of the DT and DD HTML elements, which are used with a description list element to represent terms and descriptions. A web designer would style these elements using cascading style sheets to present our address book contacts to users. As well as an HTML skeleton, a Razor file includes embedded C# code in the form of a template. There are lots of different ways of doing this. In our example, we've made use of a helper that's used to take the properties from model objects and embed the model properties into the HTML output that's sent back from the server to the client. The final member in an MVC triad is the controller. The controller receives the request from the user's browser and is responsible for coordinating the response back to the browser. In ASP.NET MVC, controllers are classes written in C# code. The class contains a set of methods. Each one of these is called an action method. There's a default convention that's used to map URLs against the class name and action method. In our example, imagine that our application was running on a server located at http://mycorp.com. The contacts controller and details action method would be used to handle a request from a browser using that base URL, followed by /contacts, the name of the controller, then /details, the name of the action method. This would then be followed by a number that corresponds to the ID of one of our contact objects or one of our contact records in the database table. In the body of the details method in our controller, we've written code using Microsoft Entity Framework to get a record from SQL Server and return it as a contact object. The controller passes this object to the corresponding view, which formats it and returns it to the user's browser. This slide shows just how little code is required to connect a model to a database using Microsoft Entity Framework. As a developer, all you have to do is inherit from the dbContacts base class and add a property using the generic dbSetCollection of your model class. Entity Framework will automatically create a database with a compatible schema for your model class if it doesn't already exist, and ensure that your model objects can be created, retrieved, updated and deleted in that database. I've already mentioned that Visual Studio offers a great developer experience for coding ASP.NET MVC applications. Simply use the Web Project template and select the MVC option. You'll be able to automatically integrate your users' existing Windows logins to get a seamless login experience against your new enterprise web application. One nice thing about writing ASP.NET MVC applications with Visual Studio is that the development environment will scaffold nearly all of the MVC code for us. All we have to do is to code the model and supply a class that knows how to map this model to the database with Entity Framework. Once you've finished writing your code, then you'll also find it straightforward to publish your application to Internet Information Services using Visual Studio's integrated web deploy. And Google have made it even easier to deploy to Compute Engine virtual machines from Visual Studio using Google Cloud Tools.